On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, P0135 may point to a problem in the heated oxygen sensor heater circuit. The truck may seem to run normally, or it can have emissions and fuel control issues while the sensor is getting up to temperature. Broadly, the possible fault areas are the ignition feed and fuse, the heater control circuit, the heated oxygen sensor heater itself, or the ECM driver. We're going to handle it like an electrical diagnosis. Verify the concern first, then prove the feed side, prove the control side, and only then make a call on the sensor or module. The heated oxygen sensors are used for fuel control and catalyst monitoring. Each sensor needs to reach operating temperature before it can give an accurate signal, so the heater element shortens that warm-up time. The heater gets voltage through an ignition voltage circuit and fuse. With the engine running, the ECM controls the ground side through the HO2S heater low control circuit, using pulse width modulation to maintain the sensor temperature range. For P0135, treat the running conditions as monitor gates, not as a long checklist to memorize. The related enabling faults need to be absent. Ignition voltage must be between 10 and 32 volts. The HO2S must be at operating temperature, and the heater must be commanded on. Once those conditions are met for 120 seconds, the monitor can run once per drive cycle. For this target code, the ECM is watching HO2S1 heater current. P0135 can set when that current is greater than 3.1 amps or less than 0.3 amps for greater than 8 seconds. In the same heater diagnostic family, the HO2S2 heater logic is listed as current greater than 2.9 amps or less than 0.3 amps for greater than 8 seconds. That is context only, because this episode stays focused on P0135. Typical scan tool heater current data is listed as 0.2 to 1.5 amps, so use the scan data as part of the picture, but still prove the circuit before condemning anything. Before getting into pin testing, start with the basic system checks and follow a structured diagnostic approach. If other codes are present, check what they mean first so you are not chasing a heater code that is being affected by another condition. Then turn the ignition on and run the engine. With the scan tool, command the appropriate HO2S heater from 0% to 100%. Watch the heater control circuit low voltage, open circuit, and high voltage test status parameters for the correct bank and sensor. The expected result is that those parameters do not display malfunction. If malfunction does not display during the command test, reproduce the operating conditions for the monitor. You can also reproduce the conditions that were captured when the fault occurred. Then verify that P0135 does not reset. If the code does not set, the system checks out at that time. If it does set, move into circuit testing. For circuit testing, turn the ignition off, disconnect the hardest connector at the appropriate B52 heated oxygen sensor, then turn the ignition on. First, check the feed side. A test lamp should illuminate between ignition voltage circuit terminal 2 and ground. If it does not illuminate and the fuse is good, turn the ignition off. Remove the test lamp and test the ignition circuit end-to-end for less than 2 ohms. If the circuit measures 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, verify the fuse is okay and that voltage is present at the fuse. If the test lamp does not illuminate and the circuit fuse is open, turn the ignition off and test for infinite resistance between the ignition circuit and ground. If you measure less than infinite resistance, repair the short to ground on that circuit. If the circuit shows infinite resistance, test all components connected to that fuse and replace components as necessary. If the feed side test lamp does illuminate, move to the control side check. The test lamp should not illuminate between ignition voltage circuit terminal 2 and control circuit terminal 1. If it does illuminate there, turn the ignition off and disconnect the harness connector at the K20 engine control module. Then test for infinite resistance between the control circuit and ground. Less than infinite resistance means repair the short to ground on the control circuit. Infinite resistance at that point points to replacing the K20 engine control module. If the test lamp does not illuminate between the ignition feed and the control circuit, remove the test lamp and turn the ignition on. Now look at the scan tool HO2S heater control circuit high voltage test status for the correct bank and sensor. The expected result is OK. Keep in mind that less than 10 ohms of additional resistance on the ignition voltage circuit or the control circuit may set a DTC. Also, when there is resistance in the circuit, the driver can remain on and the high voltage test status can still display OK. Performing this testing may set additional DTCs. If that high voltage test status is not OK, turn the ignition off, disconnect the harness connector at the K20 engine control module, and turn the ignition on. Test for less than 1 volt between the control circuit and ground. If the reading is 1 volt or greater, repair the short to voltage on the control circuit. If it is less than 1 volt, replace the K20 engine control module. If the high voltage test status is OK, install a KEN-A fuse jumper wire between control circuit terminal 1 and ignition voltage circuit terminal 2. The scan tool high voltage test status should now show malfunction. This test may only be performed once per key cycle. If you need to repeat it, turn the ignition off, allow the ECM to shut down completely, then turn the ignition on again. If the scan tool parameter does not show malfunction during the fused jumper test, turn the ignition off and disconnect the harness connector at the K20 engine control module. Test the control circuit end to end for less than 2 ohms. If the circuit measures 2 ohms or greater, repair the open or high resistance in the control circuit. If it is less than 2 ohms, replace the K20 engine control module. If the scan tool parameter does show malfunction during the fuse jumper test, the circuit response is correct. At that point, test or replace the B52 heated oxygen sensor. After completing the repair, verify the repair and confirm the code stays gone. If a heated oxygen sensor was replaced, perform the scan tool heated oxygen sensor resistance learn reset. The takeaway is simple. For P0135, do not guess at the oxygen sensor. Prove the ignition feed, fuse condition, control circuit behavior, scan tool status response, and ECM side circuit integrity in order. For more diagnostic training, visit stepdiagnostics.com.